Hello, guys, and welcome back to the Python track, Jenko. So today we're going to be talking about a much funner lesson. I think you guys are going to enjoy this lesson a lot. And there's two reasons why we're going to do this lesson first, right? So I do want to talk about classes and methods and all that kind of stuff, but we're going to push that back to lesson 8. But this lesson is going to actually give you a little introduction, right? And it's going to be a little fun way to get you into that thing, because this is very similar to what we're going to be doing in that particular lesson 8 next week. So before we go into this lesson, which is honestly going to be my favorite lesson that I'm going to be teaching to all of you, and I think you'll enjoy it. We're going to talk about what we did in the previous lesson. So in the previous lesson, we talked about functions, right? So if you haven't checked that video out, please check that before you go into this one, because this is kind of going to I'm going to be talking about a little bit about functions maybe within this presentation. So if you don't know a good grasp of functions, loops, whatever we did in the past few lessons, make sure you check those videos out before you go into this lesson. So without further ado, let's just jump into the Python lesson. And this will be lesson 7, which is turtle graphics modules. So here's a nice image of what we're going to be doing. It's kind of cool, I think. So we're going to be talking about the turtle graphics module. It's a built-in Python it's really a built-in method, a library in Python. So all you got to do is import just how you would import math and get all its features, right? When we import math, we could get pi, we could do all these kind of things with the math module. The turtle module is the same thing. We just have to import turtle, which is already built in Python. And at the end of this presentation, I'm going to show you a good demonstration on Python. So why we're going to be doing this lesson? Well, this is going to, like I said, this is going to help us with the next lesson, which is going to be lesson 8. And this is going to be talking about methods, classes, and all that kind of stuff in the next lesson 8 and 9, obviously. So objects and classes are going to be a big thing that we're going to be jumping into now in the next 2 weeks of this Gen Code Python track. But this is going to be this turtle method, this turtle module is located in the Python standard library. So it's already a built-in module in Python. And obviously it's called turtle graphics. So why is it called turtle graphics? We're going to explain that in the next slide. So the turtle graphics module, right? So the turtle graphics are basically a simple but powerful way to draw things on a coordinate plane. So if you ever thought about drawing something, like let's say you got a piece of paper, right? And you're in an art class, and I want you to draw a square, a triangle, or even draw a circle, like the basic geometric shapes. All you gotta do is get your pen on the paper and draw those particular shapes. I could draw the square on the paper, I could draw a triangle, or I could draw a circle. Well, in Python, there's a good feature called turtle, and turtle actually will draw those kind of shapes when you tell it what to do by giving it particular commands or methods, right? And this is how this is going to tie into classes in the next 2 lessons. So this is just a little introductory of how we're going to jump into that. So basically, the turtle is known as the pen, right? So it's going to draw whatever you command it to draw. So if you want to make a square, you tell it the commands of how the turtle should move and draw that square or that triangle or that circle. So it's so like I said, the Python so turtle is in the basic Python standard library, and you must import this module when you want to use it. So just like with the math module, we import math, right, to get the pi feature, whatever other like the pi feature, obviously, right? So if you want to get 3.14, you have to import math, because Python doesn't know what pi means unless you import math. Same thing with turtle, right? It won't know what turtle is until you import that module. So to always get started, import turtle. just like in the example right here. Just say import turtle, and that's all you need to do to use that feature. So here's some continuation of that previous slide. So the turtle module defines some new classes of graphical things. Once you import the turtle module, you can create a graphic screen and a turtle, right? So you could create the screen, which is known as the paper that we draw on, and the turtle, which is known as the pen we use with our hands. Use them as constructors. And here's a basic formatting of how a constructor syntax is. It's the variable name. So whatever you want to call it, like you want to call your turtle Shelly, you want to call it Leo, or you want to call it turtle, or you can name it anything. Basically a variable name. That will be your turtle's name. Then you use the module name, and the module name is always in lowercase letters, right? You start with lowercase, and the class name, which is always capitalized. And a constructor, and then now you're probably wondering what a constructor is, right? So a constructor is a method, which is kind of like a function. So if you haven't known what functions are, you want to probably look at lesson 6, which we talked about functions. And like in every function, it takes a parameter in a closed parentheses. Remember, parameters go into the parentheses. So it's the function. It's in the previous lesson I showed you. It's def, the function name, whatever you want to call it, and inside the parentheses you pass in an argument, which is known as a parameter. So below is a nice example of what this slide actually shows, right? So whenever you want to use turtle in Python, we have to import it, right? So we're going to import that module. So we say import turtle, right? So right here, import turtle. We create a graphic screen. So we call a variable called a screen, and we set that equal to turtle, which is the module name, right? This is the module turtle, and the class name, which is the screen, because we're creating a graphical screen. This is the class name. And notice the module name is always lowercase and the class name is always uppercase. This dot is known as telling it this dot means it wants you to command to make that screen. It's like a command, kind of. The dot's telling you, it's giving you orders what to do. So it's telling the turtle what to do. And here's the shell, and then we call a turtle. So this could be named anything. In this case, we named it Shelly, right? Shelly is the turtle. We set that assigned to turtle, which is again the module name, and we assign it equal to the class name, which is turtle. And again, the module name is always lowercase, while the class name is always in uppercase. Just so you're aware of that. This is a big key in this lesson, because in next 2 lessons, this is going to become very critical for you to know. So make sure you get this down and understood. So now you're thinking how we're going to draw these shapes, right? How we're going to draw it on our coordinate plane or the screen that Python's going to build. And I'll show you what I mean by this when I go into PyCharm and actually do this for you. And you can follow along as well by opening your own, open your PyCharm and following along with this video. So we're moving a turtle, right? So you want to move it. So a turtle has a position, right? Just like whenever you put a pen, it always starts at a particular orientation or position on the paper. Same thing with the turtle, right? The turtle has a position on its graphic screen. So when the screen comes up, the turtle's already going to be facing in the center of the screen, and that's its initial position. To change that position, we will use some methods, right? So you use the dot, tell this turtle to do this, right? So whenever you use the dot, it's basically saying turtle, do this, right? So some of the commands we could use with turtle is the forward or the back statement. And whenever you want the turtle to go forward, you type in turtle dot forward. In this case, we're going to be using, we named our turtle Shelly. So Shelly is the turtle. We're going to tell Shelly to move forward by using the dot. Shelly dot, go forward, and you want it to go forward 100. Then you want to Shelly dot right. So now you want to turn the turtle. You want to turn the turtle. You want to tell Shelly to turn right 90 degrees. So that turtle is going to flip 90 and it's already going to face the down position. So it went from its initial position to a 90-degree position. And these are so again, these are the commands you will be using, right? To change any orientation, to change the position, you want to use the forward or back, and to change its orientation from its standard initial orientation, you want to use the right or left or back, right or left. So if you want to change it facing down, you want to change it to the right. If you want to face the turtle up, you change it to the left. You always have to face the turtle's position. So think of how where the turtle is. You have to look at it from that perspective, where you want the turtle to turn left or right. And again, so in this particular jump, an object or the instant of the class, right? This in this case, the object is Shelly, right? We named the variable Shelly, so Shelly is our object of this turtle class. Then we have the dot operator. Again, the dot operator right here. It tells Shelly, the dot is basically saying, do this, right? You want Shelly to go and it's giving it a command. So dot is basically, when you ever use the dot operator, it's telling you, it's giving it a command. So in this case, in this example, it's showing Shelly dot. And now you want Shelly to go, you want to give it a command. I want Shelly to go forward. So the turtle is going to go forward 100. And then at the end, I want Shelly to turn right. So I'm putting the dot. I want it to turn right 90 degrees. And another, so then you have to name the method. So these are methods, right? Then after the dot, this is the method. This is your object. This is your method. So the object Shelly we're putting the method forward. So we're telling Shelly to go forward, or we're telling Shelly to go right. And in the parentheses, it's going to be our parameter, right? It's basically the parameter list, right? So we're telling Shelly to go 100 and 100, the number 100 is the parameter, or 29 degrees is the parameter, just like how we used in functions. So here's a fancier way we could use the turtle, right? So turtles has enough, the turtle module also has other features known as, you could change its colors, you could change its width attributes, whatever you want to do just to make it look fancy. So you could change the color, the initial color of the turtle will be black. But if you want to change the color, if it's the color you want to like green or blue, you just pass in Shelly command color, right? So you wanted to change the color, you throw in the color method and you throw in the parameter of the color, and that is the color blue. So if you want to change the pen from black, the turtle from black to blue, you just throw in that method, Shelly.color, passing the parameter blue in as a string. And if you want to change the width of the turtle, you throw in that method, right? Shelly, the turtle, the object, the method width, and the parameter 10. So if you want to change that size to 10, if you want to change the width to 10, you just pass in that command. So a method is basically a function that applies to a particular object using the dot operator with the syntax. So again, object name, the dot operator, which is like giving it a command, and the method, and inside that method, and next to it, it's going to be the parameter being passed in inside the parentheses. And here's the example, right? I'm going to actually show this I'm going to show some similar examples on Python, so we could run it and see how this actually runs in real time. But this is an example of drawing a blue triangle, right? We're giving it a size of the turtle, which is 100, and then we create a turtle, which is, we're going to call the turtle blue T, right? In this case, the last one, remember in the last slide, we named our turtle Shelly. Well, it doesn't really matter. You can name it anything. In this case, they named the turtle blue T, and we set that equal to the turtle.turtle. Remember, this is the so remember, this is we start with the turtle and and the total dot total. So in the previous slide, we talked about what that really means is we have the module name and the class name, right? So remember, always in lowercase, it's always going to be the module name, and in the uppercase, it's always going to be the class name. So always make sure it's going to be the module, which is always lowercase, the class, which is always going to be capital. So we call total, and then we use our object blue t, which is the total we created, and we throw in the methods like change the color of blue t to blue, change the width of blue t to 10, and then telling blue t to move forward t size, and t size is equal to 100. So it's every time we're going to move it, every time you pass in t size, it's going to move 100. That is our parameter. And then we want to turn it right 120. And this will actually create a triangle, the blue triangle. And I'll show you this in the Python. And here's some other total methods we haven't seen this slide, but these are some of the other methods you can throw. So remember, to move the total, always you can use forward or you can use backwards. You can move the total forwards or backwards. To rotate the total's orientation, change it from the right to the left. To draw a circle, it's pretty straightforward. You just have to you have to take your object to the total object and pass in the circle method, and it will draw the circle. And to raise and lower the pen, you go up and down. You want to move go to a different position. Remember, the total is always going to start in in the center, always like in a coordinate plane where the origin is always going to start at the origin. So if you want to move that total position a little bit up or down, you just use the go to and it'll move X and Y on the X and Y coordinate plane. And remember, some of these other ones I passed, like the color, you can change the color of the total, you can change its orientation, and you can change the width of the line, the thickness of the line, you could change as well. So here's a recap of today's GenCode lesson on total graphics. So what we take away from this is these 4 bullet points, right? A Python module is a file that contains Python code, right? Usually defining one or more related new types of things or a class, right? So in this case, our module will be the total, right? The total module is already built in as a module. Each class defines a type of object and it constructs a method to create a new object of that specific type. And each class method or function for doing things with an object of that type, we use the dot operator. Remember, the dot operator is like a command. It tells the object what to do. So whenever you throw the dot operator, you throw in the method afterwards, and it'll tell that object to do this. It's the dot method. Think of it as a command or an order. And by conversation, remember, a class name is always capitalized, right? And the object and the method names are always in lowercase, right? So if you have any questions, comments, or concerns, please just email us at gencode.us@gmail.com, and we'll get back to you as soon as possible. And if you need to recap this video, you can always replay it. This will be uploaded onto GenCode as well as the YouTube channel. So if you always want to replay this video, look at it. And if you need questions of what functions are, what we talked about, parameters and all that kind of stuff, please just check the previous lessons, right? Actually, lesson 6 was about functions. So if you haven't got the hang of functions yet, make sure you watch that video or any of the previous videos, because this is actually just building onto those previous videos. So with that being said, this presentation is concluded, and I'm going to jump out of this presentation and I'm going to go into Python, and I'll give you some cool examples before I sign off. So let me go into Python. So this is your Python, right? I already created a file, so we're just going to jump right into the code. So we want to use the total graphics. So first thing we always do is what? Import, right? So let's import, right? And in this case, we want to import the total module. So we say import total. And now, next step is we want to create a screen or that paper, right? Like anytime you want to draw something, you need a piece of paper. So in this case, we need to create that piece of paper. And by doing that, we're gonna call a screen, just screen. You can name it anything you want. I just call it screen. Just a simple thing. And we pass in this message screen dot screen, and that will take care of that. Actually, it should be total dot screen, sorry. Total dot screen, because we always remember that's the module we're using with Pattern module and the classes screen. So screen is set equal to total dot screen. Again, you can name this anything. You can call this a screen if you want. I'm just gonna call it screen. That's a simple reference. And then we want to create a total. So you can name this anything you want. Let's call this total Leo, right? We're gonna call the total Leo. It's a cool name, I think. And we pass in the module, which is total, and the class, which is total. Again, remember, the class module is always lowercase. The class is always uppercase with the parentheses afterwards. Same thing up here. This is the module total, and then we use the screen. Now this screen is the class, so that's uppercase. And now we're ready to create our drawings. So let's draw something pretty straightforward. Let's say I want to just draw a triangle, right? What we could do is we command Leo, that's our object. We command it using the dot operator. We want it to what? We want Leo to go forward. Remember, the position of the total is always in the center. Think of a coordinate plane. And the center of that coordinate plane is the origin. It always starts at the origin. Let's move it forward. And in this case, let's just move it forward 100. Now, depending on which way you want to draw the triangle, you want to draw it this way, or you want to draw it that way. It depends on which way you want to turn the total. So I just want to draw a straightforward up triangle. So let's turn the total. So now remember, the total position is always, let me bring up the notepad actually. I think this will actually help you a little bit understand what I'm trying to say. So let me draw it for you. So yeah, that's a pretty bad drawing, but that should be there. So your total is going to look like this pretty much. So let's say we want to draw the triangle, right? We already moved the total 100. So now the total is facing this way, right? Still, we just moved it 100. Now we want to draw the triangle this way. So what we want to do is change the position of the total. Now think of it. The total position is, you have to change it towards the total point. You want to change its orientation. The total is facing straight, right? You want to turn it left. So which way is the total's left? It's this way, right? We want to go this way if you want to draw it this way. So you turn it left this way. So the tool is going to, we call it left, and we want to change it, and we want to turn it left at a particular angle. We don't want to turn straight left. We want to turn it at an angle. So the angle is pretty simple to calculate, right? Think of a circle, right? How many degrees in a circle? 360, right? So let me just get the notepad out. It's 360 degrees in a circle, right? To calculate the angle of a triangle, which how much do you want that to turn? We want to turn, we have to take 360 and divide by how many sides a triangle has. So a triangle has 3 sides. So we take 360, divide by 3, and that would be 120, right? So we want to turn the total left 120. So the total is going to change in this, we want to face this way, right? And go forward up left, and then go forward 100 in that direction. So let's go back into Python. So we're going to turn it left. And again, we're turning it at an angle of a triangle. So we're turning it 120. And again, then you go T dot forward again. Again, you're going to tell it to go 100. And now you're at that position. Now you want to turn the total back this way. So you turn it left again, right? Total position facing this way, turn it left. So your total is facing this way right now up here. So you want to change it in this direction. I'll show you right here. It's facing this. So you want to turn it left to go back this way. And you want to turn it back left 120. So this way it goes. To complete that triangle. So theta Leo dot left and change it 120. That should create the angle. Now you have to just go theta forward again one more time. And that should create our triangle. Right? There you go. So let's run this and see what we get. And there we go. We got that triangle. I'll run it again. I know that was pretty quick, but see how the total is actually moving every time I'm running this. But now, sometimes you want to change it back into its initial position. So you just change, turn, let's say Leo left and change it 120. That's just to put the total back in its initial position where we started. So instead of facing this way, it'll face back straight again. So let me show you that. See, it changed it back straight. I know that's pretty quick, but that's how it's worked. But it's pretty cool, right? It drew a triangle. Now, I don't want to keep doing this over and over with the forward, left, forward, left, forward, left. It just gets too repetitive. So you guys learned something in the previous lesson in this Python gen code I taught you it was a few lessons ago, and that was on loops, right? So I think that was lesson 4. So if you really need to recap on that, go back to lesson 4, and that would be talking about loops. But we could use loops in this particular case. So instead of doing this 3 times, see, I did it 1 time, 2 times, 3 times. I just want to change this code and shrink it to 2, just to this, right? And to do this, you need to throw in a loop. So remember, if you don't know what a loop is or have to do the loops, please just go back to lesson 4, and that will show you all about what loops are. I will give you a refresher on loops. So in this case, we're using the for loop. So we're going to go for I in range, right? And we're going to go how many times we want this to go. We want it to run 3 times. Colon. And remember, in Python, indentation matters. So always indented. And this should still run the same thing with just less lines. And it still drew the triangle, right? But instead of writing this 3 times, I only have to write it 1 time, the 2 commands, right? Because I used the loop. So this is actually makes the code more efficient and less repetitive. Now, this is a pretty straightforward example of how total works. Now you could play around with this a lot. If I want, let's say I want to draw a square, right? Square has 4 sides, so we want to run this 4 times. And the angle has to change, right? It cannot be at 120. How many sides the square has? It's 4, right? And 360 divided by 4 is 90. So we want to change this. We want to turn this 90 degrees. So change this left, Leo dot left, 90, and that should draw us a square now. See? It drew the square on the coordinate plane. So that was a pretty fun lesson. I really like total module. That's the one cool thing I like about Python. It has this feature. If you need more recap on what this lesson was, now this lesson wasn't just about the total and drawing stuff. It was more about you getting to know how methods work, how classes work, right? And I give you a little taste of that in this lesson. So this will actually help you prepare. It'll make more sense when we go into lessons 8 and 9, where we're going to talk about methods and classes, right? And how they work. So this was just a little taste of what it's supposed to be, but in a fun way. So this is why I really wanted you to do it. I hope you guys will engage by this too. It's pretty cool, the total. if you want to keep making more pictures or drawings of turtles, play around with this, right? I showed you, and you can look it up on Stack Overflow if you want to look at more examples. YouTube it, even go back to my Genko videos, this Genko video, and look at what I did and try to figure it out how you can do this on your own. This is pretty straightforward, I think. It's just a fun way to get you into the classes and methods, but in a fun way where you could draw pictures using Python. And you could do a lot of cool things with Turtle. This was just one of some of the basic stuff I was teaching. But if you want to go more into this, feel free to learn it on your own time. If you have any questions, like I said, just go genco.us@gmail.com, and we'll respond right back to you as quick as we can with answers to your questions. So with that being said, I'm going to sign off, and I hope you guys have a wonderful day, and I'll see you in the next lesson, which we're going to be talking about Python classes, methods and classes. So have a wonderful day, and I hope to see you soon. Bye.